Ever wonder how a typical roller coaster works? Let's take a look at the physics behind the ride. What powers most roller coasters after the climb to that initial big drop?
Roller coaster motion relies primarily on conservation of energy, the conversion between potential and kinetic energy.
Outside of the external work imparted on a roller coaster to climb to the top of the big drop, the ride observes this conservation of mechanical energy. Conservation of energy. Total energy is equal to potential energy plus kinetic energy, and remains relatively constant, minus the energy lost to air resistance and friction. Based on the conservation of energy, total energy equals potential energy, mass times gravity times height, plus kinetic energy, which is 1/2 mass times velocity squared. One can calculate the velocity at the bottom of the drop, as well as other points along the roller coaster path. Following the car through its range of motion on the big drop, it has a maximum potential energy with minimal kinetic energy at the top of the drop, and maximum kinetic energy with minimum potential energy at the bottom of the drop. Why does it feel like I am weightless at the top of a roller coaster loop, and weigh a ton when I get to the bottom of the loop? To explain that phenomenon, let's talk about forces exerted and the perceived effect on the rider.
The feeling of weightlessness while upside down is the result of the rider accelerating with the roller coaster car. Forces act in the same downward direction, so the car exerts a minimal force on the rider. The feeling of extraordinary weight at the bottom of the loop is the result of the car rapidly slowing its rate of descent and forcing the rider to do so as well. So the roller coaster car exerts an upward normal force on the rider. This set of free body diagrams shows how the force vectors result in this perceived weight at various points on the loop. Notice the significant difference in apparent weights at the bottom and top of the loop. This animated example shows how the rider experiences various forces exerted by the roller coaster car throughout the motion of the ride. You will notice that most conventional roller coaster loops are not circular, but a clothoid shape, where the entrance and exit radii are much larger than the radius at the top. This provides a reduced rate of change in forces exerted on the rider, as he or she enters and exits the loop feature, and provides a safe, exciting experience for riders of all types.